Tyler, I have a question.
Uh-huh.
How do you take the square root of -1?
Exactly. That's why I said, do you agree with what I wrote here? So it's kind of, there's not a direct way to get from here to here because of what you're saying. But so we kind of approach it the other way, where I'm going to say to you, what would happen if I squared everything here? I'd get this. Okay? All right. So let's start testing some endpoints. So we're going to test x equals -1. We plug that into our original series. So that's going to become -1 to the n. Then -1 to the 2n plus 1 all over 2n plus 3. So these have the same basis, so I can go ahead and combine, add those exponents. Maybe I should back off a little bit and go the other way. So this becomes -1 to the 3n plus 1 all over 2n plus 3. And notice in the original series it goes from 0 to infinity, so does mine. So just for kind of grins, I'm going to go write out a few of the terms. So when n equals 0, this is going to go something like this. -1/3. When n equals 1, it's +1/5. When n equals 2, this becomes -1/7. Okay? So this is a alternating series, so we got a 1, 2, 3. If you don't know what 1, 2, 3 is, you're going to have a long week. Use of n is 1 over 2n plus 3. So let's go through our list. Are all the use of n's positive? Yep. Is use of n plus 1 less than or equal to use of n? Are the terms decreasing? Yes. Is the limit as n tends to infinity of 1 over 2n plus 3 going to 0? Yes. So by Leibniz, we converge, correct?
Isn't it technically not decreasing because it goes from -1/3 to 1/5, or does that only apply to?
You're looking at the individual terms, right? Because this is like 0.333, this is 0.2, and we're only looking at use of n. We're not looking at the sign. That's why we call it use of n, and not, oh, I see what you're saying.
Yeah.
Well, these terms are really the a terms, right? But the u part is without the alternating sign. And that's why Leibniz, that's why it works, to be honest with you. Okay. Now, okay. So, we converge. So now what we would do is we would say that we would include that endpoint. So notice I write or equal to. Now we need to test the other point. Test x equals 1. So this time we are going to rewrite our series. This time it's 1 to the 2n plus 1 over 2n plus 3. And 1 to any power is just what? 1. So I can kind of remove that. And all I'm left with is -1 to the n over 2n plus 3. So again, this one is alternating. And it's basically the same series, except instead of starting with a negative, we start with a positive. So to write out a few terms, it's 1/3 minus 1/5 plus a 1/7, and so on. So use of n is the same as above. So we already know by Leibniz it's going to pass. So we know by Leibniz it converges. So we are also including that endpoint. So for part A, the interval of convergence would include both endpoints. So moral of the story is, if you don't